Hi, this is Jean Bedourde. Today I'm going to talk about adapting your search strategies to different database structures. At this point, you may feel overwhelmed by all of the options available when you use a professional search engine. So I'll try to simplify the process. You learned about Boolean operators, proximity connectors, and truncation in the previous unit. The next step is determining which field you want to search. The default is to search all fields, but power searchers improve their results by limiting searches to fields. Every ProQuest dialog database has a corresponding ProSheet, which details the fields available in that database. By the way, all search engines have fields, but there's usually little documentation for the searcher. Advanced searching allows you to select individual fields by using drop-down menus for each box. In command searching, you can use field codes found in the ProSheets. In the first example on this slide, only the title field, denoted by TI, is searched using the term Time Warner, which is a company name, plus the search term cable, and requires that both of these search terms be present in the search results. Parentheses are used to limit the search to the title field. In the second example, the same search is executed in both the title and the abstract field. In practice, it's very common to search both of these fields together. Now let's look at the results for these searches. I executed these searches in ABI-Inform, which is a database for business researchers. The first query searches only the title, so these records are very likely to be about Time Warner, the company, and its cable business. The second search in both the title and the abstract retrieves all of the articles in set 1, but also additional articles. These may be about Time Warner competitors or about the cable industry. The second search retrieves almost 3 times as many records as the first search. Set 3 shows the use of the Boolean not to show how many additional records were selected by adding the abstract field to the search query. All 3 of these sets, by the way, are much too big, so I would add additional filters to get a manageable set. Typically, I'd add date, so only the last year or 2 were included. And then depending on the query, I would also exclude wire feeds, since these tend to be product announcements. In the last set, I've deliberately made a mistake, so there are 0 results. This is my clue to go back and fix the syntax. That's why I prefer to break up complex searches into smaller queries that are easier to troubleshoot. I'm always reviewing the number of results in each set to see if they are reasonable. Your assignment for this module includes downloading and reviewing 2 ProSheets for databases that are also available on the open web. These sheets document the design decisions made by both the database producer and the ProQuest dialog. There are a lot of nitty-gritty details, particularly for highly indexed bibliographic databases. Most searches don't require that level of detail. The examples on the ProSheets, however, can be quite useful. For most researchers, and novices in particular, the old 80-20 rule works very well. You only have to understand a limited number of fields to do most of your searching. This slide, as well as the lecture, identifies the fields you really need to understand to be able to do an effective search. These are the different types of databases I discuss in the lecture. You need to adjust your search strategies to each type. Index citation databases have the smallest records and the fewest number of words to search. Abstracts are the most common aggregated databases and the most useful for subject searching. However, both of these require the additional step to get full text. Full text databases usually have lots of words, and the articles can be very long, but subject indexing is often limited. As a researcher, I prefer to read an abstract to determine whether an article is relevant before perusing a long article which may or may not be relevant. The final type, hybrid databases, are just that, different types of articles relevant to a subject area. There will be long and short articles in the same database. An index citation database has short records, usually consisting of a title, bibliographic citation, and subject headings. This means you will need to include synonyms in your search since the number of words is limited. A good strategy is to find several relevant records, then look at the subject headings and search on those with the next iteration of your search. Abstract databases are the core of research. Typically, the abstract is meaty enough to determine whether the full text is needed. Often, the abstract provides enough information. It's common to search both the title and abstract together, sometimes combined with subject headings. The primary advantage of a full-text database is that you don't have to go to another source for the full text. It's common practice to search just the title and abstract, or lead paragraph, rather than the full text itself to reduce the number of false hits. Full-text databases tend to have limited subject headings because they're from primary publishers who don't do cataloging. The key to success is understanding the content of the databases you are searching. Power searchers use different search terms depending on the database. You need to be aware that subject indexing varies widely from database to database. The best strategy is to start with the most unique term in your query. Sometimes this is sufficient. Look at your results. Are the records relevant? You may need to change search terms. Is the result set too large? Add limiters to reduce the number of results. Don't start out with a long, complicated query. Chances are it won't work. Look at the size of the sets and the first couple records to evaluate your search, then refine it by building additional search sets. Step by step works better since you can see the results at each point. Do experiment by trying the same searches in different databases and look at your results. Try variance. As you do more searching, these concepts will make more sense. Now let's go search.